is Kepler's equations for one parabolic orbit. That is part of the handouts today, but I'm going to point out, let's write it up just here, okay? So that is 2 mu divided by p, and basically for parabolic always p equal to a, and t minus t is 0, and will be equal to tangent to anomaly plus 1/3 tangent to anomaly squared minus so basically this one is saying if we have a parabolic orbit, and say if this is our focus, and so corresponding this is nu 0, and this is t0, and to here this t, and this is nu. So that is the notation of the symbols here. So this is nu 0. Okay. And this one usually people define this as the m, and m is the symbol we're going to use in the handouts. So I simply just define the symbols for you. For this one, again, the easy problem is this, is to given the nu and find t, given nu and nu 0, find time of flight t minus t0. Okay, and the hard one is vice versa, is we given t minus t0 and nu 0, find nu. Okay, and luckily either way, basically this is equations, and this equation basically is involving a certain constant. For example, say 3 equal to m equal to tangent nu and minus plus 1/3 tangent cube nu square. Okay, so this equation is involving something like this one, and again we can solve for this numerically, but I would say luckily, and we have an analytical solution for this. Okay, so let me give to you. Using these equations, and we'll see what happened. and I'll let you finish writing this equation. Basically, the contents of the equation here, they are the same. And one is 1/3 of the roots, and the other is minus 1/3, and that's it. So we look at these equations, and probably a few more seconds, let you finish. Ready? Okay. So with that equation, you can see this is the solution to these problems. So from here, you can see for the easy problems, we are given nu and nu 0. So we can punch calculators to determine tangent and tangent cube, and we can determine the time of flight easily. And now we look at the hard problem. The hard problem is given t minus t0, which means for the hard problem, we are given the value of the m. So with this equation, if we know the value of m, we simply plug into this equation, we can determine tangent mu. So that means we can determine this one. So basically, for parabolic equations, we have the two equations. Basically, there's no such definition of easy or hard. We can always calculate, determine either way by hand. Okay? Good. So that is this one. Because this one is very straightforward, and let me leave the examples exercise later. I want to erase this part and go to the hyperbolic. Okay, anyone good? Okay. The second one, hyperbolic. And this one, again, we have is nu and divided by minus a cube. And if you remember, when we talk about hyperbolic orbit in chapter 1, when we review conic sections, and we use this one, and in our notation, again, in our textbook notation, this value of a for hyperbolic is intrinsically negative. So we put a negative sign here to make the whole thing positive. So don't feel weird. And that is a way we try to make everything consistent. Okay, and that is a symbol used in our textbook. Okay? Okay, and then we continue here. So t minus t0, and will be equal to, again, e hyper sine f. I will define f shortly. Minus e hyper sine minus basically f is the symbol used for eccentric anomaly for hyperbolic. So here we have the similar formulas. I think here one is hypertangent, one only is tangent. So the same thing here, this for the hyperbolic orbits, we have a similar computational rigors. So look at here, if we are given nu to anomaly, we are able to determine f, eccentric anomaly. So that means the right hand side is a number we can calculate quickly by calculators. So that means when we are given nu, we can easily calculate time of flight. On the other side, if we given the time of flight, then this is the hyper functions, then we wouldn't be able to solve it by hand. So if we are given this value on the left-hand side to solve for f, then we have to go to numerical approach. Okay, so that is defined as the easy and hard problem in terms of the computational rules. So this one we done this section. Now